As we have all learned in this course, climate change can have many profound impacts. For example, it can change ocean circulation patterns, modify habitats, and produce acid rain. These are just some of the many consequences of climate change. What may not be known, however, is that increasing carbon dioxide concentrations because of climate change can alter the nutrient profile of our crops. Over 2 billion people are estimated to be deficient in one or more nutrients, and climate change can potentially add more people to this group. If this results in undernutrition, it will lead to the degradation of the body and especially affect vulnerable groups of people. So me and Farouk, we will examine how increasing CO2 concentrations can change the quality of our food.
The bulk of recent CO2 increases are anthropologic in origin. Volcanoes also contribute CO2, but human activities such as land clearance, industrial emission, are larger by a factor of more than 100. In the edible portion of crops, there are many nutrients including proteins, vitamins, and trace elements. Trace elements are elements required in small quantities for consumption by the human body, like iron and zinc. These nutrients repair our body, provide the body with energy, and help regulate metabolic process in the body. Did you know that 63% of dietary protein, 81% of iron, and 68% of zinc come from vegetable sources? It has been found that the increased CO2 will change the nutrient content in many of these crops that we consume. The iode of plants are all the nutrients and trace elements in organism, which includes carbon and other nutrients. CO2 is fixed in the process of photosynthesis, which produce carbon. Increases in CO2 can disproportionately increase carbon relative to other elements, which alters the nutrient profile of our food. In experiments done on plants, two types of plants, carbon-3 and carbon-4 plants, that fixate carbon differently were analyzed. These are two categories of carbon-3 plants, which includes grasses and legumes. Rice and wheat fall under the carbon-3 grass, while soybeans and peas fall under the carbon-3 legumes. The carbon-4 grass analyzed was maize and sorghum. The plants are primarily grown under the free air carbon dioxide enrichment method, where the plants are in atmosphere with different CO2 concentrations from Earth. These are also grown in open top chambers and growth chambers. This experiment took place across the globe, tested over 1 to 6 growth seasons at 546 to 586 parts per million, which is greater than the approximately 411 parts per million we are currently at.
Using a combined data set from the types of growth methods, both carbon-3 and carbon-4 plants saw decreases in zinc, iron, and protein. In units of micrograms, wheat had the greatest decrease in zinc content at a 9.1% decrease. Meanwhile, rice had the smallest decrease in zinc at 3.1%. When it comes to iron, wheat also had the greatest decrease in iron at 5.9%, with rice and maize at 4.9% and 5.8% respectively. Interestingly enough, sorghum had a 1.6% increase in the amount of iron. In regards to protein, rice had the greatest decrease in protein content at an 8.2% decrease, and wheat had a 7.2% decrease. Except for sorghum, every other crop decreased in all the nutrients, with soybeans having an exceptionally minimal increase in iron content at 0.1%. The reduction in nutritional content could have heavy implications. CO2 levels are expected to surpass 550 parts per million by the middle of the century, which is around the ppm that was tested. As discussed, the effect will be an increase in global undernutrition. On top of the billions already deficient in nutrients, an additional 175 million more people, which is around 1.9% of the population, could become deficient in zinc, while 122 million more people, which is around 1.3% of the population, could become deficient in protein. The type of nutrient source plays a huge role in nutrient vulnerability. Poorer populations usually have a more vegetal-based diet, which naturally makes them more susceptible to nutrient deficiency. Rice accounts for 25% of the global caloric consumption and is one of the most important nutritional sources in low-income countries, especially in Asia. As of 2013, 600 million people, primarily in Southeast Asia, consume greater than 50% of their protein from rice. This region would be quite susceptible to nutrient deficiency due to reliance on rice. Iron and zinc deficiency account for 5.7% of disability life years lost, which is a measure of health burden. This issue would only increase the health burden on people.
All this sounds depressing, right? An obvious solution would be to reduce CO2 output by using emission-free methods of transport, recycling, and practicing efficient behavior at home. These are some ways to reduce CO2 output. Unfortunately, this issue is far more complex than these tasks. Some good news is that there are possible ways to mitigate this problem before it occurs. Biofunification, which is the process of increasing nutritional value of crops, is a way of solving this problem. Golden rice is a type of rice produced through genetic modification. This rice is meant to be grown with the intention of addressing vitamin A shortage. This is different from regular rice as it produces additional beta-carotene, an antioxidant that directly converts to vitamin A. Selective breeding uses seed from crops yields that are highly nutritious. This can be crossbreeded with crops of high yield. This technique is less controversial than genetic modification. A greater varieties of food types can also solve this issue. Countries that have dietary heavier in animal source food are at much lower risk. This is because meat have greater density of nutrient than plants.
So to sum up this topic, increasing CO2 concentrations can change the quality of our food. This reduces important nutrients in food, which further compounds on the already vulnerable. This could be potentially fixed by genetic modification and selective breeding. While humans are the main cause of this, humans can also be the ones to solve this issue.